everyone. Over the last few lessons, we have been learning about parallelograms and how parallelograms used to be rectangles that just shifted a little bit and became kind of slanted. Now we're going to talk about triangles and how triangles also used to be a rectangle or a square and how they've just changed a little bit. So in our lesson today, we're going to be looking at how do we find the area of a triangle? Well, in order to find the area of a triangle, we first need to think about a square. So I have here my little square, and this square has 4 equal sides. It has 4 vertices, and in these corners, you can see that they are 90-degree angles. There's several different types of triangles, but all triangles come from either a parallelogram or they come from a rectangle or a square. And so one thing I want you to think about is that a triangle is just a square or a rectangle folded in half. So we start with a square and we cut it in half and we have a triangle or 2 triangles. So one thing for us to think about is that a triangle is half of a square. So I have my square, and I've just, so much dog hair, and I've just simply cut it in half. That's it. A triangle is half of a square. I could draw my square or my rectangle or whatever, and I just cut it right in half. I have 2 equal sides. If I were to cut this correctly, I would have had 2 equal sides of this rectangle. So 2 becomes half. So a half of a triangle. Notice we have a right angle on our triangle. We have a right angle. We also have a height, right? So if this is the height, here we have the height, and then this shape also has a base. So base and height, and it's half. So our formula for solving for the area of a triangle combines all of these parts. We combine 1/2, we combine the height, and we combine the base. So area is half of the base times the height, or half of the height times the base. It doesn't matter how you write it, it all means the same thing. So half of the base times the height. So let's go ahead and see how this looks in action, and we are going to go from there. And because I'm always going to say the area equals half of the base times the height, I'm going to write it like this because that way it doesn't confuse you. So let's go ahead and look at example A. And example A is a right triangle. Now there's different types of triangles. There's right triangles, isosceles triangles. There we go. And this triangle that I have here has a height of 8 inches and a base of 5 inches. And so in order to solve for this, I'm just going to use the same formula that I have on my paper, and it says area equals half of the base times the height, and I'm going to fill in for the different things. So first of all, I know that the height is on the right angle. So there's my height. So where I see the height, I'm going to put an 8. The base is the bottom of the shape. So where I see the base is 5. I'm going to put a 5 there in the B. And now half is going to just remain the same. Now, maybe I don't like multiplying or doing by fractions, so I could just multiply these two things and then divide by 2 because it's all the same thing, right? So 1 times 5 times 8 gives us 40, and 40 over 2, see, you're just dividing by the half, which equals 20. 20 inches squared. Or you could just say 5 times 8 is 40, and 40 cut in half is 20. Either way is fine. You could do half of 8 is 4, and 4 times 5 is 20. You can move these numbers around and work with them because the commutative property says that you're allowed to do that. You can multiply them in any order, as long as you're multiplying and then using division, like the order of operations, like a fraction. Okay? All right, let's do another example. Like I said, sometimes we have different types of triangles. Well, this triangle, this next triangle we're going to look at, happens to look kind of like this. So it doesn't have a right angle. Okay, it doesn't have one. So they will give you a right angle. They will tell you what the right angle is. And usually they use a red, like a red line to show you that information. So they'll actually come out here and they will draw a red line and give you the height. So that way you're still able to solve. Now, the whole length of the base is not from here to here. The base is still just from blue to blue. And it says right now that the base is 12 meters. But the height, so wherever there's a right angle on this triangle, maybe the right angle was here, the right angle on this triangle is 9 meters. So again, we're going to use that exact same formula. We're still going to say 1/2, half of the base times the height gives us the area. So let's plug in what we know. We know the base is 12. So where I see the base, I'm going to put 12. Where I see the height is 9. So I'm going to put 9 there. And then I just have 1/2 again. So I'm going to multiply it by 1/2. And that equals the area. So 12 times 9, or I could do half of 12, which is 6, and 6 times 9, and solve that way. You get the exact same answer no matter how you do it. So 6 times 9 gives us 54, or you could do, so half of this is 6, and 6 times 9 equals the area, and 54 meters squared equals the area. Or if you wanted to, you could multiply 12 times 9 and then divide that by 2, and that would give you the exact same answer. So again, the biggest difference between parallelograms, notice how this could be a parallelogram right here. If we were to finish drawing, it could slant this way so that the corners match up. A triangle is just half of whatever we've been working with. So I'm going to go ahead and turn the page now, and I'm going to do have you do your triads. So just remember that half, a triangle is just half of a rectangle, a square, a parallelogram. So whatever you're working with, whatever you're doing, you're just going to be taking half of it, solve just like you did before, but then, again, take half. Take half. Okay, so let's go ahead and do your triads. So triad number 1 is a triangle that looks like this. Again, it's really important to remember that the height is on that right angle. It's really important for that. 10 meters. And then the base is 22 meters. Okay, there's number 1. Number 2. Let's solve this one. Solve. Now, if for some reason we were solving for the missing dimension, just like we did, you would still plug in, but they would give you the area first, and you would plug in what you know and isolate the variable, just like you were doing before. This is 8 centimeters, and this one is 15 centimeters. Let's go ahead and do one where you have to isolate for the variable and solve. So on this one, use the right triangle. And the height is 4. We don't know the base, but the area equals 44. And these are feet. Okay, go ahead and hit pause right now so you don't hear me solving. And then when you are ready, come on back and hit play so you can check your level of understanding. So the first one, you have 10 and 22, 8 and 15, and then 4 feet times base equals area of 44. So you're solving for the missing variable. Okay, let's see here. Number 1, again, I'm just going to do half times base times height. So the base is 22 times 10 for the height. The height here is on the right, and that's half. So 22 times 10, or I could just do half of 22 or half of 5. Either way, I get the same answer. So 22 times 10 is 220. I'm going to cut that in half, and that's going to give me 110 meters squared. 110 meters squared. Okay, the next one that we're looking at is this triangle here. We have a base of 15 and a height of 8. So we have a base, so we're going to use that same formula. Area equals half of the base, which is 15, times the height, which is 8. Again, we're going to just solve this going straight across. You could do half of 8. We know that's 4, and 4 times 15. That gives us 60, because 30 plus 30 is 60. So area equals 60 centimeters squared. Again, we're squaring it because it's the area that we have found. How are you doing so far? How are you doing on these? Are you getting them right? Okay, let's do this last one. So this last one is the exact same thing that we did with the parallelograms. So the same thing that we did with parallelograms, except you just have to put in the height, right? So we're going to use the same formula. Area equals 1/2 times the base times the height. We're going to plug in what we know and then solve for what we don't know. We know the area is 44. Okay, we know we're looking at 1/2. The base is B. We don't know the base, but the height is 4 because it's on the right angle here. So now we're ready to solve this problem. Half of 4, right? Half of 4 is 2. So 2 times the base equals 44. Half of 2, divide by 2 to isolate that variable. And that tells us that B equals 22. Okay, how did you do on this one? All right, it is your turn now to answer your essential question. How do we find the area of a triangle? Go ahead and put your answer there, and then write your level of understanding out to the side. How do we find the area of a triangle? Where are you at with this? 1, I have no clue what you're doing, Miss Englander. There's just a bunch of numbers on the page. 2, I kind of get it. It's the same thing. I just have to remember to divide by 2. 3, I'm doing really well with this. I know the formula, and I just have to plug in the numbers. Where are you at? Then when you are finished, you can come on back to the Google Meet and ask for help if you need it, or you can go and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.